Okay, so in this video today, we're going to start off with the questions that are about using trigonometric values, but also incorporating derivatives. Now, we're going to skip the ones that are just sketching and reading stuff off the graph questions. That's something that we did in year 11 a fair bit. If you feel like you need more practice in it, by all means, you can go back and do worked example 13 and complete some of the other questions like question 1, 2, and 3. But today we're going to be starting with worked example 14, and we're going to do question 6 onwards as the questions that we're set today. So question 6, all. Okay, so the temperature on a particular day can be modelled by this function, where T is the time in hours after 5 a.m. and capital T is the temperature in degrees Celsius. In the remaining 6 hours of the 24-hour period, the temperature remains constant. Calculate the temperature at 8 a.m. Okay, so if we are looking for the temperature at 8 a.m., we're going to find the time that's lapsed. Now, this one here at 5 a.m., that would represent when T is equal to 0. So there's been 3 hours between them. So we're going to be substituting in when the time is 3. So what is the temperature when the time is 3? That's what that statement there means. Minus 3 cos pi bracket 3 all over 9 plus 18. Now, we're going to show you how to solve this one tech-free. If it is a tech-active question, you'd be silly to not shove it into your calculator right now. But let's see how it is tech-free, and then we're going to go through what to do in your calculator. So over here, T3. This one will cancel out with that one, making that 30 degrees. Anytime we've got pi on 3, we know we're looking at 60 degrees. Now, using our exact values, cos of 60 degrees is going to give me a half, plus 18. So this can be simplified into minus 1.5 plus 18. And when I chuck that into a calculator or do it in my head, 18 minus 1 will make 17. So it'll be 16.5 degrees Celsius when the time is equal to 3. So therefore, at 8 a.m., the temperature is equal to 16.5 degrees Celsius. At what times of the day is the temperature 20 degrees Celsius? Give your answer correct to the nearest minute. So for B, we now want to know, when is the temperature 20 degrees Celsius? What is that time? Okay, so we're going to go over to our calculators. Now, again, you'd be silly to not just chuck this in and use G-solve if you could, because all I'm really trying to solve is 20 is equal to negative 3 cos pi times T over 9 plus 18. So if I'm rearranging to solve this, I'm going to take the 18 across first, which will leave me with 2. Then I can take the 3 across, so 2 over negative 3 is equal to cos pi T on 9. Take the inverse cos across. Okay, I don't want to chuck this in a calculator straight away. I'm just going to do it the lazy way. So I'm going to take the 9 across by timesing this side by 9 to get rid of it over here. And then I'll divide by pi to get rid of that pi. So this will give me the value that I'm looking for. So when I chuck that into my calculator, so this would be in an exact form. If I had an exact value in here, then I would be able to find the angle straight away. But we don't, so we'll just chuck it over into our calculator over here. So 9 divided by execute. Okay, so that's when our time is equal to 6.59. Okay, so looking pretty good so far. Next thing we're going to do is this one, find dt over t. Now, one thing that you guys might be a little bit confused about is when when do I have it in radians? When do I have it in degrees? So generally, this question doesn't state anything about radians or degrees. Therefore, I leave it in radians. Now, this over here is also a bit of a hint that you're going to be leaving it in radians. But if it doesn't state anything to you about it being a question that is in degrees, then it's in radians. Over here where it says degrees Celsius, that is the unit that we use on this side of the equation, not for the T. So that's how I know that this question is not going to be in radians. Now, this question asks us, at what times of the day is the temperature going to be 20 degrees Celsius? We haven't actually finished. So I'm going to need to, this is an extension of question B, I'm going to need to work out what time of the day that occurs. So 5 plus 6.59 is going to give me 11.59. So that's going to be PM, right on the cusp. And then if I want to convert this into being hours and minutes, it's going to be 11 hours plus 0.59 times 60, because there's 60 minutes. So 0.59 times 60 equals, so it's going to be 11:35, AM, not PM, AM. Okay, because this 11.59 represents that this will occur when it's 11.59 of an hour. So that's what we did. Okay, now that's only the first one. Now, like I said to you before, we would be silly to not use solven in this case. So in order to do that, I'm going to go option, calc, solven, and then I'm going to plug in the original thing that I would have had there without any of the rearranging. Now, every time that we rearrange something, there is a possibility that we're going to make an error, which is why it's better to just chuck it in at this point here. Because if I chuck it in here, there's no room for error. Comma X, that stops things from going wrong. Okay, there we go. So we found, now these ones here to start off with will not be in our domain, but I probably do have some others that are going to be in my domain. So we're going all the way up from 0 to 18. So you can see here that one's not. That's the one that I just found. My other solution will be 11.41. And then that one's out of the domain as well. So it'll be 5 plus 11.41, because that's the other one that is included in our domain. So that's going to be equal to 16.41, which is going to be 16 plus 0.41 times 60. .41 times 60. Yeah, what's happened? 60 times 0.41 to work out how many minutes are made up of 0.41 of an hour. So that's going to be 24 minutes. So 16 and 24-hour time is going to be 4 p.m. And 25 minutes if I round. So it's going to be, if I write that out nicely instead of like a crazy person, 4:25 p.m. So that's when I'm going to have the second time where the temperature hits 20 degrees Celsius. Okay, so now I'm going to rub some of this out so that we can do the next part. So all of the stuff that we've done so far is stuff that we would have been able to do from doing year 11. Now, the next part is find the change in temperature with respect to the change in time. So we want dt over dt. So we're going to be deriving our original function of t with respect to time. So in here, I'm going to write the normal equation that we had before to show that I'm deriving the equation. Okay, so when I take the derivative of this function here, negative 3 is going to be at the front, multiplying the derivative of cos pi t over 9, and then plus 18 doesn't have any t's to give us. So when I take the derivative of this term here, I just get 0. So that part vanishes. So now I'm going to take the derivative of the inside of this bracket, because we're essentially applying chain rule here. So the derivative of the inside of this bracket will give me pi on 9, multiplied by cos will turn into minus sine, and then I put it back. Now, this is something you should have been practicing on your skill sheets each week. So now I can use some cancelling. So this and this will become positive. 3 divided by 9 will leave a 3 down here. So this is going to become pi on 3 sine pi t on 9. Okay, and that will be the derivative of our function with respect to time. So that is the derivative there. What is the rate of change of temperature at the times found in B corrected 2 decimal places? So that is another way of saying that we're going to let T equal. Now, we're looking for this one, and this one is the numbers that are going to be substituted in. So let T equal 6.59 and 11.41. So all I'm going to do is chuck it in. Negative 3, make sure your calculator is still in radians. You shouldn't have changed it. But get used to checking every time that when you put something in the calculator, it is in fact in the right mode. Now, it's taken the answer at the front there. I'm just going to delete that back. Okay, so I've got that function. I've input... Now, I almost made a mistake then. What is the rate of change of the temperature? Which means I want to let T equal these values in dt over dt. So I'm not substituting it into that one. I am going to be substituting it into this one here. So we'll say that one there is equal to pi on 3 sine pi 6.59 over 9. I'm going to get an answer. So pi divided by 3 sine pi 6.59 all over 9. Close that bracket. Press execute. Okay, so the rate of change of the first one is 0.78. And for the next one, I'm just going to go back through my initial formula. Delete, 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 delete. Put in that second number. And negative 0.78. Now, there was another way that we could have done this. Not necessarily faster, but again, if you were in an exam situation and you wanted to make sure you weren't going to derive this thing incorrectly and then substitute into your incorrect derivative, I would go over here and press the d over dx button. In this section there, I'm going to input our original function, negative 3 cos x over 9, just like that. Close that bracket, plus 18 on the end. So your original function is going in there, and then you're telling it that you want to then let x equal 6.59. So if I do that, boom, you get that first answer. I could have gone back in, deleted the old answer out, execute, and there you go. Now, there is one other way that we could have got this. We'll show you another time. Okay, bye.